Europeans first encountered the extraordinary platypus in 1798. 200 years later, we barely understand even the simplest aspects of its life. Piecing the evidence together has proved a fascinating detective story. Helping us to unravel the mystery is a 21st century platypus scientist, Tanya Rankin.
When the first platypus skin was sent to England, the scientists there thought it was a hoax. And they poked and prodded and jabbed at this thing and thinking that it was a bill attached to a skin, but no, it was a real animal. Some of the scientists almost took it personally that there was this mammal that did not fit their classification. They had this rigorous idea of what a mammal was, what a reptile was, what a bird was, and the platypus was a little bit of each of those. But it took at least 100 years before it was actually absolutely confirmed that they laid eggs.
Egg layers, like the platypus or echidna, and marsupials, like the possums, both have a quite extraordinary birth process. 25 years ago, when filming Life on Earth, we may have failed to film the platypus birth, but we did make some progress, because for the first time ever, we filmed this: newborn opossums moving from the birth canal to the mother's pouch. But the birth itself happened so quickly, and the babies are so small, that we thought we'd missed it. Only when we looked at the film frame by frame did we see the moment of birth in this Australian possum. But this is a scientific image, not a natural one. That was the challenge this time around. We've been getting pictures of what goes on in a breeding burrow or a nest hole for some time. The standard way of doing that is to set up a breeding colony and then provide them with an artificial nest hole in which you already have pre-formed holes in which you can put your camera lenses. But that wouldn't work with duck-billed platypus. Platypus had never been bred in captivity. It would have to be done in the wild. And one of the first people to do such a thing in the wild was Simon King, who worked with another creature that lives beside rivers and burrows holes in the bank. Not a mammal, but a bird, the kingfisher. How do the two compare? Kingfishers are brightly coloured, spectacular birds, not common, but very conspicuous. Not so the platypus.
Platypuses are really difficult to see in the wild. They're brown, they come out at dusk, very low profile in the water, so you could be walking past one, you wouldn't even know it.
They live in similar places. This is a typical platypus river, while Simon found his kingfishers in a Somerset peat cutting. And when an adult bird flies into a hole carrying a fish, you know that she's got young inside. But that's not possible with a platypus. Because a female feeds her young with milk, you can't tell whether one is a mother or not. Tanya needed technology to locate a nest burrow.
I do a bit of work with radio tracking, looking at their movements and what sort of habitat use they have of the river. And through this, I track them to their burrows during the day and find out where the burrows are, where the nesting chambers are.
And once Tanya had located a burrow, Mark Lamble handled the camera work. Birds are a joy. Once they have chicks, their bond is very strong and they'll return to the nest. With patience and careful observation, you can use pretty large-scale methods to look inside that nest. The platypus would be far more sensitive to disturbance. This meant that it was one turn at a time for Mark. It took 10 hours in the sun before they could insert the probe. The first burrow wasn't used as a nest. It's painstaking work, and the final stages are similar for both teams. Finally, Simon filmed the behaviour he was looking for. And after 3 nests, I saw inside a burrow for the first time. Thanks to Mark and Tanya.
It was just an incredible experience because it was something that had had never been done before, to actually look inside a living, active burrow. It's so hard to describe the experience. It was just incredible.
And finally, I saw the image I'd waited 25 years to see.
That little baby platypus that we caught on camera could not have been more than 3 centimetres long. I mean, probably shorter than the length of my thumb, tiny thing. And the colour of it just amazed me. It just never occurred to me that you would get a magenta platypus. It was just astounding. And so it was something that I really learnt a lot about the workings inside a burrow, even the structure of the nest, with the way the leaves lie, what they're made of. It just gave me such a better understanding of the ingenuity of these animals.
Although we've discovered a great deal about the platypus in recent years, we still don't fully understand the function of that extraordinary feature, its bill. It's rubbery, covered in skin, with a good blood supply and a lavish network of nerves. The platypus brain has a larger area receiving nerves from the bill than from either its eyes or ears. So what exactly is the bill detecting?
An early naturalist, Harry Burrell, always thought that platypuses had to use some sort of a sixth sense because they close their eyes, ears and nostrils underwater, yet they can capture such tiny prey as insects, shrimp, that sort of thing. It wasn't until about 1986 that scientists actually ran experiments with platypuses just using a small 9-volt battery and seeing whether platypuses could sense that underwater, and they were astonished at the results because this is a sensory system that has not been found in any other mammal.
It's called electroreception, and the detectors are tiny pits on the bill. Magnified 1,000 times, this is what they look like. They're incredibly sensitive, detecting the tiny electrical currents that are given off by muscle activity and that carry very well in water.
So the tail flick of a shrimp can be picked up as a sense by the platypus. They use this electroreception both for hunting prey but also for navigation underwater. So they do this kind of triangulation thing with the electrical sense and then this delayed physical movement of the water, and they pick that up with these bills integrated inside their brains, and they manage to collect up enormous amounts of food. They can eat up to 25 to 30% of their body weight in food every night. This is tiny little insects that they're picking up.
The platypus can read a riverbed in a very different way to us. Even trying to visualize how the system works is a challenge. And what it shows us is that far from being a joke, the platypus is a unique animal that has developed some very special and very successful features at the dawn of the life of mammals.